Hello friends, welcome to i-TUTOR NCERT series. Today we are going to discuss Class 11 Geography NCERT Fundamentals of Physical Geography Chapter 5 Geomorphic Processes. Let's start. The Earth's crust is dynamic. It has moved and moves vertically and horizontally. It moved a bit faster in the past than the rate at which it is moving now. The differences in the internal forces operating from within the Earth which built up the crust have been responsible for the variations in the outer surface of the crust. The Earth's surface is being continuously subjected to external forces induced basically by energy. The internal forces are still active though with different intensities. That means the Earth's surface is being continuously subjected to by external forces originating within the Earth's atmosphere and by internal forces from within the Earth. The external forces are known as exogenic forces. Okay, so the external forces which are known as exogenic forces, and the internal forces are known as endogenic forces. Okay. The action of exogenic forces result in wearing down, that is degradation of the relief or elevations, and filling up, that is aggradation of basins or depressions on the Earth's surface. Okay, so the exogenic forces causes wearing down of the relief or elevations and filling up or aggradation of basins or depressions of the Earth's surface. The phenomenon of wearing down of relief variation of the surface of Earth through erosion is known as gradation. The endogenic forces continuously elevate or build up parts of the Earth's surface, and hence the exogenic process failed to even out the relief variations of the surface of the Earth. So variations remains as long as opposing actions of exogenic and endogenic forces continue. In general terms, the endogenic forces are mainly land building forces and exogenic processes are land bearing forces. Okay, so endogenic forces means they are land building and exogenic forces means they are land bearing. The surface of the Earth is sensitive. Humans depend on it for their sustenance and have been using it extensively and intensively. So, it is essential to understand its nature in order to use it effectively without disturbing its balance and diminishing its potential for future. Almost all organisms contribute to sustain the Earth's environment. However, humans have caused extensive damage to the environment through overuse of resources. We must also leave it potential enough to sustain life through the future. Most of the surface of the Earth had and has been shaped over very long periods of time, and because of its use and misuse by humans, its potential is being diminished at a fast rate. If the processes which shaped and are shaping the surface of the Earth into varieties of forms and the nature of materials of which it is composed of are understood, precautions can be taken to minimize the detrimental efforts of human use and the perspective it for posterity. Okay, so this is an introduction about the geomorphic process. Okay, so here we discussed about two types of forces, that is first one is the external forces and second one internal forces. Okay, the external forces are known as exogenic forces and the internal forces are known as endogenic forces. Okay, the endogenic forces are land building forces and the exogenic forces are land bearing forces. Okay, so these are the main things we discussed here. Now moving forward, geomorphic processes. The endogenic and exogenic forces causing physical stress and chemical actions on Earth's material and bringing about changes in the configuration of the surface of the Earth, and this is known as geomorphic process. Okay, so what is geomorphic process? The endogenic and exogenic forces causing physical stress and chemical actions on the Earth's material and bringing about changes in the configuration of the surface of the Earth. Okay, they bring changes on the configuration of the surface of the Earth, and these are known as geomorphic process. Diastrophism and volcanism are endogenic geomorphic process. These have already been discussed in brief in the preceding unit. Okay, so we'll discuss about the diastrophism and volcanism coming chapters. Now, weathering, mass wasting, erosion and deposition are exogenic geomorphic process. Okay, so the weathering, mass wasting, erosion and deposition, these are some of the exogenic geomorphic process. Any exogenic elements of nature, that is water, ice, wind, etc., capable of acquiring and transporting earth materials can be called a geomorphic agent. Okay, so any exogenic elements, that is water, ice, wind, etc. Okay, so these are capable of acquiring and transporting earth material can be called geomorphic agent. When these elements of nature become mobile due to gradients, they remove the materials and transport them over slopes and deposit them at lower level. Geomorphic process and geomorphic agents, especially exogenic, unless stated separately, are one and the same. Now, a process is a force applied on earth material affecting the same. An agent is a mobile medium, that is like running water, moving ice masses, wind, waves and currents, etc., which removes, transports and deposits earth material. Running water, groundwater, glaciers, wind, waves and currents, etc. can be called geomorphic agent. Okay, so the running water, groundwater, glaciers, wind, waves and currents, these are called geomorphic agents. Okay. Now, gravity, besides being a directional force activating all downslopes movements of matters, also causes stresses on the Earth's material. Indirect gravitational stress, active, wave and tide include induced currents and winds. Okay, so the indirect gravitational stresses, active, wave and tide induced currents and winds. Without gravity and gradients, there would be no mobility and hence no erosion, transportation and deposition are possible. Okay, so without gravity and gradients, there would be no mobility and no erosion, transportation and deposition are possible. So gravitational stresses are as important as the other geomorphic processes. Gravity is the force that is keeping us in contact with the surface, and it is the force that switches on the movement of all surface materials on the earth. All the movements either within the earth or on the surface of the earth occur due to gradients from higher levels to lower levels, from high pressure to low pressure areas, etc. Okay, so that is about the geomorphic process. Now, endogenic process. The energy emanating from within the earth is the main force behind endogenic geomorphic process. This energy is mostly generated by radioactivity, rotational and tidal friction and primordial heat from the origin of the earth. Okay, so the energy emanating from within the earth, that is the main force behind endogenic geomorphic process. Now, this energy due to geothermal gradients and heat flow from within induces diastrophism and volcanism in the lithosphere. Due to variations in geothermal gradients and heat flow from within, crustal thickness and strength, the action of endogenic forces are not uniform and hence the tectonically controlled original crustal surface is uneven. Now, diastrophism. What is diastrophism? All processes that move, elevate or build up portions of earth crust come under diastrophism. Okay, so the all processes that is move, elevate or build up portions of the earth crust that come under the diastrophism. They include orogenic process involving mountain building through severe folding and affecting long and narrow belts of the earth's crust. Then epeirogenic process involving uplift or wrapping of large parts of the earth crust. Then third, the earthquakes involving local relatively minor movements. Now fourth one, the plate tectonics involving horizontal movements of crustal plates. In the process of orogeny, the crust is severely deformed into folds. Due to epeirogeny, there may be simple deformation. Orogeny is a mountain building process, whereas epeirogeny is continental building process. Okay, so orogeny means mountain building. Okay, it means mountain building. And epeirogeny means continental building. Though through the process of orogeny, epeirogeny, earthquakes and plate tectonics, there can be faulting and fracturing of the crust. All this process causes pressure, volume and temperature, that is PVT, changes with in the turn induce the metamorphism of rocks. Okay. Now, what is volcanism? Volcanism includes the movement of molten rocks, that is called magma, onto or towards the Earth's surface, and also formation of many intrusive and extrusive volcanic forms. Now, exogenic process. The exogenic processes derive their energy from atmosphere determined by the unlimited energy from the sun and also the gradients created by tectonic factors. Gravitational force acts upon all earth materials having a sloping surface and tend to produce movement of matter in downslope direction. Force applied per unit area is called stress. Okay, so the force applied per unit area, that is called stress. Stress is produced in a solid by pushing or pulling. This induces deformation. Forces acting along the faces of earth materials are shear stresses. It is this stress that breaks rocks and other earth materials. The shear stress results in angular displacement or slippage. Besides the gravitational stress, earth materials become subjected to molecular stresses that may be caused by a number of factors, amongst which temperature changes, crystallization and melting are the most common. Chemical processes normally lead to loosening of bonds between grains, dissolving of soluble minerals or cementing materials. Thus, the basic reasons that lead to weathering, mass movements and erosion is development of stresses in the body of the earth material. Temperature and precipitation are the two important climatic events that control various processes. All the exogenic geomorphic processes are covered under the general term denudation. Okay, so all the exogenic processes, they are covered under the general term denudation. The word denude means to strip off or to uncover. Weathering, mass wasting or mass movements, erosion and transportation are included in denudation. Okay, so the weathering, mass movements, erosion, transportation, these are included in the denudation. As there are different climatic regions owing to variations in thermal gradients created by latitudinal, seasonal and land and water spread on the surface of the earth, the exogenic geomorphic process vary from region to region. The density, type and distribution of vegetation, which largely depend upon precipitation and temperature, also exert influence indirectly on exogenic geomorphic process. Now, within different climatic regions, there may be local variations of the effects of different climatic elements due to altitudinal differences, aspect variations and the variations in the amount of insolution received by north and south facing slopes as compared to east and west facing slopes. Further, due to differences in wind velocities and directions, amount and kind of precipitation, its intensity, the relation between precipitation and evaporation, daily range of temperature, freezing and thawing frequency, depth of frost penetration, the geomorphic process vary within any climatic region. Now, climatic factors being equal, the intensity of action of exogenic geomorphic process depends upon types and structure of rocks. The term structure includes such aspects of rocks as faults, fault, orientation and inclination of beds, presence or absence of joints, bedding planes, hardness or softness of constituent materials, chemical susceptibility of mineral constituents, the permeability or impermeability, etc. Now, different types of rocks with difference in their structure offers varying resistance to various geomorphic processes. A particular rock may be resistant to one process and non-resistant to another. And under varying climatic conditions, particular rock may exhibit different degrees of resistance to geomorphic process and hence they operate at differential rates and gives rise to different intertopography. The effects of most of the exogenic geomorphic process are small and slow and may be imperceptible in a short time span, but will in the long run affect the rocks severely due to continued fatigue. Finally, it boils down to one fact that the differences on the surface of the Earth, though originally related to crustal evolution, continue to exist in some form or the other due to differences in the type and structure of Earth materials, differences in geomorphic process and in their rates of operation. Some of the exogenic geomorphic processes have been dealt in detail here. Now, weathering. Weathering is action of elements of weather and climate over earth material. There are a number of processes within weathering which act either individually or together to affect the earth materials in order to reduce them to fragmental state. As very little or no motion of materials take place in weathering, it is an in situ or on-site process. Weathering processes are conditioned by many complex geological, climatic, topographic, and vegetative factors. Climate is of particular importance. Not only weathering processes differ from climate to climate, but also the depth of the weathering mantle. There are three major groups of weathering process. First one, chemical weathering, physical or mechanical weathering, and finally biological weathering. Very rarely does any one of these processes ever operate completely by itself, but quite often a dominance of one process can be seen. First one is chemical weathering. A group of weathering processes by solution, carbonation, hydration, oxidation, and reduction act on the rocks to decompose, dissolve, or reduce them to a fine clastic slate through chemical reaction by oxygen, surface and soil water and other acids. Water and air, that is oxygen and carbon dioxide, along with heat must be present to speed up all chemical reactions. Over and above the carbon dioxide present in the air, decomposition of plants and animals increases the quantity of carbon dioxide underground. These chemical reactions on various minerals are very much similar to the chemical reactions in laboratory. Now, physical weathering process. Physical or mechanical weathering process depend on some applied forces. The applied forces could be gravitational forces such as overburden pressure, load and shearing stresses, then expansion forces due to temperature changes, crystal growth or animal activity, and finally water pressure controlled by wetting and drying cycles. Many of these forces are applied both at the surface and within different earth materials, leading to rock fracture. Most of the physical weathering processes are caused by thermal expansion and pressure release. These processes are small and slow but can cause great damage to the rocks because of continued fatigue. The rock suffers due to repetition of concentration and expansion. Repetition of contraction and expansion. Now, final one is biological activity. Biological weathering is contribution to or removal of minerals and ions from the weathering environment and physical changes due to the growth or movement of organisms. Growth or movement of organisms. Burrowing and bedding by organisms like earthworms, termites, rodents, etc. help in exposing the new surfaces to chemical attack and assist in the penetration of moisture and air. Human beings, by disturbing vegetation, plowing and cultivating soils, also help in mixing and creating new contacts between air, water and minerals in the earth materials. Decaying plant and animal matter helps in production of humic, carbonic and other acids which enhance decay and solubility of some elements. Plant roots exert a tremendous pressure on the earth's material, mechanically breaking them apart. Now, special effects of weathering. Exfoliation. This has already been explained under physical weathering process of unloading, thermal contraction and expansion and salt weathering. Exfoliation is a result but not a process. Flaking of more or less curved sheets of shells from over rocks or bedrocks result in smooth and rounded surface. Exfoliation can occur due to expansion and contraction induced by temperature changes. Exploration can occur due to expansion and contraction induced by temperature changes. So that's already discussed. Now, exploration domes and tores result due to unloading and thermal expansion respectively. Okay, exploration domes and tores. This is the result due to unloading and thermal expansions. Okay, exploration domes is due to the unloading and the tores result due to the thermal expansion. Now, significance of weathering. Weathering processes are responsible for breaking down the rocks into smaller fragments and preparing the way for formation of not only regolith and soils but also erosion and mass movements. Okay, so the processes are responsible for breaking down the rocks into smaller fragments. Now, biomes and biodiversity is basically a result of forest, and forests depend upon the depth of the weathering mantles. Erosion cannot be significant if the rocks are not weathered. That means weathering aids mass wasting, erosion, and reduction of relief and changes in landforms are consequences of erosion. Weathering of rocks and deposits helps in the enrichment and concentration of certain valuable ores of iron, manganese, aluminium, copper, etc., which are of great importance for the national economy. Weathering is an important process in the formation of soil. Now, mass movement. These movements transfer the mass of rock debris down the slopes under the direct influence of gravity. That means air, water, or ice do not carry debris with them from place to place, but on the other hand, the debris may carry with it air, water, or ice. The movements of mass may range from slow to rapid, affecting shallow to deep columns of materials and include creep, flow, slide, and fall. Gravity exerts its force on all matter, both bedrocks and the products of weathering. So, weathering is not a prerequisite for mass movement, though it aids mass movements. Mass movements are very active over weathered slopes rather than the over unweathered materials. Mass movements are aided by gravity, and no geomorphic agent like running water, glaciers, wind, waves, and currents participate in the process of mass movements. That means mass movements do not come under erosion through there is a shift of materials from one place to another. Materials over the slopes have their own resistance to disturbing forces and will yield only when forces is greater than the shearing resistance of material. Weak, unconsolidated materials, thinly bedded rocks, faults, sleepy, dipping beds, vertical cliffs or steep slopes, abundant precipitation and torrential rains and scarcity of vegetation etc. favors mass movements. Okay, so these are some of the things which favor the mass movements. Okay, weak unconsolidated materials, thinly bedded rocks, faults, sleepy dipping beds, vertical cliffs, steep slopes, abundant precipitation and torrential rains, and scarcity of vegetation. Okay, so these are some of the favor the mass movements. Now, several activating causes precedes mass movements. They are removal of support from the below to material above through natural or artificial means, increase in gradient and height of slopes, overloading through addition of materials naturally or by artificial filling, overloading due to heavy rainfall, saturation and lubrication of slope materials, removal of material or load from over the original slope surface, occurrence of earthquakes, explosions or machinery, excess natural seepage, heavy drawdown of water from lakes, reservoirs and rivers leading to slow outfall of water from under the slopes or river banks, indiscriminate removal of natural vegetation. Now, heave, that is heaving up of soil due to frost growth and other causes. Flow and slide are the three forms of movement. Okay, heave, flow and slide. These are the three forms of movements. Now, landslides. These are relatively rapid and perceptible movements. Okay, so these are relatively rapid and perceptible movements. These are rapid movements. The materials involved are relatively dry. The size and shape of the detached mass depends on the nature of discontinuities in the rock, the degree of weathering, and the steepness of the slope. Depending upon the type of movement of material, several types are identified in this category. Slump is lipping of one or several units of rocks debris with a backward rotation with respect to the slope over which its movement take place. A rapid rolling or sliding of earth debris without backward rotation of mass is known as debris slide. Debris fall is nearly a free fall of earth debris from a vertical or overhanging face. Sliding of individual rock masses down bedding, joint, or fault surface is a rock slide. Over steep slopes, rock sliding is very fast and destructive. Slides occur as planar failures along discontinuities like bedding plants that dip steeply. A rock fall is free falling of rock blocks over any steep slope keeping itself away from the slope. Rock falls occur from the superficial layers of the rock face, an occurrence that distinguishes it from rock slides which affects materials up to a substantial depth. Now, erosion and deposition. Erosion involves acquisition and transportation of rock debris. When massive rock break into smaller fragments through weathering and any other processes, erosional geomorphic agents like running water, groundwater, glaciers, wind and waves remove and transport it into other places depending upon the dynamics of each of these agents. Abrasion by rock debris carried by these geomorphic agents also aid greatly in erosion. By erosion, relief degrades, that is, landscape is worn down. That means, though weathering aids erosion, it is not a precondition for erosion to take place. Weathering, mass wasting, and erosion are degradational process. It is erosion that is largely responsible for continuous changes that the Earth's surface is undergoing. Denudational processes like erosion and transportation are controlled by kinetic energy. The erosion and transportation of earth material is brought about by wind, running water, glaciers, waves, and groundwater. Of these, the first three agents are controlled by climatic condition. They represent three states of matter, that is gaseous wind, liquid running water, and solid glaciers respectively. Okay, so now the work of the other two agents of erosion, waves and groundwater, is not controlled by climate. In case of waves, it is the location along the interface of litho and hydrosphere, coastal regions, that will determine the works of waves, whereas the work of groundwater is determined more by lithological character of the region. If the rocks are permeable and soluble and water is available only, then karst topography develops. Okay. Deposition is a consequence of erosion. The erosional agents lose their velocity and hence energy on gentle slopes, and the material carrying by them starts to settle themselves. In other words, deposition is not actually the work of any agent. Okay, so the deposition is not actually the work of any agent. The coarse materials get deposited first and finer ones later. Okay, the coarse material deposit first and then the finer materials. By deposition, depression gets filled up. The same erosional agents, running water, glaciers, wind, waves, and groundwater, act as aggradational or depositional agents also. Okay, so the erosional agents, they are also acted as the depositional agents. Okay, now soil formation. Soil is a dynamic medium in which many chemical, physical, and biological activities go on constantly. Soil is a result of decay. It is also the medium for growth. It is a changing and developing body. It has many characteristics that fluctuate with the season. It may be alternatively cold or warm, or dry or moist. Biological activity is slowed or stopped if the soil becomes too cold or too dry, Organic matter increases when leaves fall or grasses die. Now, process of soil formation. Soil formation or pedogenesis depends first on weathering. It is this weathering mantle, that is depth of the weathered material, which is the basic input for soil to form. First, the weathered material or the transported deposits are colonized by bacteria and other inferior plant bodies like mosses and lichens. Also, several minor organisms may take shelter within the mantle and deposits. The dead remains of organisms and plants helps in humus accumulation. Minor grasses and ferns may grow. Later, bushes and trees will start growing through seeds brought in by birds and wind. Plant roots penetrate down. Burrowing animal bring up particles. Mass of material become porous and sponge-like with a capacity to retain water and to permit the passage of air, and finally a mature soil. A complex mixture of mineral and organic products forms. Now, soil forming factors. 5 basic factor control and formation of soils. First one, parent material, then topography, climate, biological activity, time. So these are the 5 factors which control the formation of soil. In fact, soil forming factors act in union and affect the action of one another. Okay, so parent material, topography, climate, biological activity and time. These are the 5 basic factors which control the formation of soil. So first one, parent material. Parent material is a passive control factor in the soil formation. Okay, so this is a passive control factor in the soil formation. Parent materials can be any in situ or on-site weathered rock debris, that is residual soils, or transported deposit, that is transported soils. Soil formation depends upon the texture, that is sizes of the debris, and structure, that is deposition of individual grains or particles of debris, as well as the mineral and chemical composition of the rock debris deposits. Nature and rate of weathering and depth of weathering mantle are important consideration under parent material. There may be differences in soil over similar bedrock, and dissimilar bedrocks may have similar soil above them. But when soils are very young and have not matured, these show strong links with the type of parent rock. Also, in case of some limestone areas where the weathering process are specific and peculiar, soil will show clear relation with the parent rock. Okay, so that's about the parent material. Okay, now second one is topography. Topography, like parent material, is another passive control factor. Okay, so this is also another passive control factor. The influence of topography is felt through the amount of exposure of a surface covered by parent materials to sunlight and the amount of surface and subsurface drainage over through the parent materials. Soils will be the thin on a steep slopes and thick over flat and upland areas. Over gentle slopes where erosion is low and percolation of water is good, soil formation is very favorable. Soils over flat areas may develop a thick layer of clay with a good accumulation of organic matter, giving the soil dark color. Okay, so that is the importance of the topography. Now climate. How climate affects the soil formation? Climate is an important active factor in soil formation. The climatic elements involved in soil developments are: first one, moisture in terms of its intensity, frequency and duration of precipitation, evaporation and humidity. Second one, temperature in terms of seasonal and diurnal variations. Precipitation gives soil its moist content, which makes the chemical and biological activities possible. Excess of water helps in the downward transportation of soil components through the soil and deposits the same down below. In climates like wet equatorial rainy areas with a high rainfall, not only calcium, sodium, magnesium, potassium, etc., but also a major part of the silica is removed from the soil. Okay, sorry. So, in climates like wet equatorial rainy areas with high rainfall, not only calcium, sodium, or magnesium, potassium, but also a major part of silica is removed from the soil. Removal of silica from the soil is known as desilication. Okay, so what is the removal of silica from the soil is known as desilication. In dry climates, because of high temperature, evaporation exceeds precipitation, and hence groundwater is brought up to the surface by capillary actions, and in process the water evaporates, leaving behind the salt in the soil. Such salts form into the crust in the soil known as hard pans. In tropical climatic areas, tropical climates and the areas with intermediate precipitation condition, calcium carbonate nodules are formed. Okay, the calcium carbonate nodules are known as concur. Okay, now the temperature acts in two ways: increasing or reducing chemical and biological activities. Chemical activity is increased in higher temperature, reduced in cooler temperature, and stops in freezing condition. Okay, now the chemical activity is increased in higher temperature and reduced in cooler temperature, and it stops in the freezing condition. That is why tropical soil with higher temperature show deeper profiles, and in frozen tundra region soil contain largely mechanically broken material. Now, final one is biological activity. The vegetation cover and organisms that occupy the parent material from the beginning and also at later stages help in adding organic matter, moisture retention, nitrogen, etc. Dead plants provide humus, the finely divided organic matters of the soil. Some organic acids which form during humanification aid in decomposing the mineral of the soil parent material. Intensity of bacterial activity shows up differences between soil of the cold and warm climates. Humus accumulates in cold climates as bacterial growth is low. Okay, so the humus accumulates in cold climates as bacterial growth is very low there. With the undecomposed organic matter, because of low bacterial activity, layers of the peat develop in subarctic and tundra climates. In humid tropical and equatorial climates, bacterial growth and actions is intense and dead vegetation is rapidly oxidized, leaving very low humus content in the soil. Further, bacteria and other soil organisms take gaseous nitrogen from the air and convert it into a chemical form that can be used by plants. This process is known as nitrogen fixation. Rhizobium, a type of bacteria, lives in the root nodules of the leguminous plants and fixes nitrogen beneficial to the host plants. Okay, so the rhizobium bacteria, they mainly found in the root nodules of leguminous plants. They convert the atmospheric nitrogen into nitrates. The influence of large animals like ants, termites, earthworms, rodents, etc. is mechanical, but it is nevertheless important in soil formation as they rework the soil up and down. In case of earthworms, as they feed on soil, the texture and chemistry of the soil that comes out of their body changes. Now the final one is time. Time is the third important controlling factor in soil formation. The length of the time the soil forming process operates determines maturation of soil and the profile development. A soil becomes mature when all soil forming processes act for a sufficiently long time developing a profile. Soils developing from recently deposited alluvium or glacial till are considered young and they exhibit no horizons or only poor developed horizons. No specific length of time in absolute terms can be fixed for soil to develop and mature. Okay, so that's about the chapter. If you have any doubts, you can comment below. For more videos, do like, share, subscribe.